Hello and welcome to this tutorial series on linear electronics. Now in this tutorial we are going to focus on LTspice. We'll be using LTspice for simulations, like for simulating our circuits. You know, electrons are not very easy to visualize, and the flow of currents in a circuit, voltages along nodes can be very difficult to visualize, okay? And sometimes too, when you are solving problems, you may want a way to verify your work as to whether you are doing the right thing or not. LTspice is a tool designed by Analog for simulating circuits, and we are going to use it extensively in this course. So without talking much, let's get into it. So this is LTspice. If you don't have it installed on your PC yet, just go to google.com and then search for LTspice. Alright, so we'll go over the interface and design a simple circuit, and we are going to simulate it just to get familiar with LTspice. Alright, so when you open it, you are going to see a blank screen like this. Now what you do is you click on this icon for a new schematic. Alright, so even the new schematics looks kind of blank, but let's see. Let's go over some of the items here. Let's see. So we have the file menu, we have the edit, the hierarchy, view, simulate, tools, window. Alright, so let's look at the menu bar here. Sorry, the toolbar here. So we have the new schematic, the open schematic, save, control panel. This is run. These options are for zooming, and this is for selecting traces. We will look at that later. And we use this one to arrange windows on the screen. We use this one to delete, this one to copy, to search. Let's head over to this side. So this tool here is used to draw wires. This is the ground symbol. This is a net label, symbol for resistor, capacitor, inductor, diode. And this is the symbol for any additional component which is not on this toolbar here. This is to move items, and this is to drag items. Alright, so in this tutorial we are going to design a simple zero crossing detector. A zero crossing detector, as the name suggests, is supposed to detect when a waveform is actually crossing the zero line. So inside of our circuit we are going to supply a sinusoidal AC waveform, and then we are going to observe the output. Okay, so without much ado, let's get into it. So we are going to be using an op-amp here. So I'll click here and then select my component. Alright, so when this window shows up, you can actually browse through this list, or if you know the name of the item you are looking for, you can simply type it here. So I'll be using a known operational amplifier. I'll be using the LM358. Okay. Alright, there you go. Alright, so next up I'll be needing some basic components. So I'll be needing a diode. Alright, this is a diode. I can actually press D for diode. Okay, and I want to rotate it. You press Ctrl R to rotate. Alright, let me place that here. Let me place it here. Alright, next up I would want a capacitor. I'll just press C for capacitor. C. So use a scroll wheel to actually move things around, and you drag this window to actually move the entire work around. Alright, so I'll need two resistors. I'll press R for resistor. So one here and Ctrl R, then one there. Okay, I'll need another resistor for the output to serve as my load. So Ctrl R, Alright, so I'm going to add the voltage source. So I'll head over to components. Then I'll just type voltage. Okay. Let me place it here. Alright, so once you are done using a certain tool, you can just right click to disable it. Okay. Alright, so I'm going to add my ground. I can just press G on my keyboard. Let me move this guy over here. So I click on this tool here, then I click on it, and then I move it. Alright, so next thing I would like to do is to wire things up. So I'll press F3 on my keyboard, or I can simply click on this guy over here. I'll just press F3. Okay. Let me move the pump up a bit. Alright. Let me connect the output. You actually get to understand the operations of op-amp in later videos. Okay, we are just doing this one to be familiar with the software, that's all. So don't worry about understanding the circuit or its operation. When we learn about op-amps, things will become very clear to you. Alright, let me add another ground here. Then let me add another voltage source. So I can just use this to copy and paste here. I just click. I have to rotate it. Okay. And then get my ground. F3. Okay, so we are done connecting things. The next thing is to assign values to our components. Okay, so I'll start with the AC source. I'll just right click on it to edit the value. I'll head over to advanced. Now I need a sine wave, and I want its amplitude to be 312, and then the frequency of 50 hertz. Then I'll just click OK. Alright, so you can see it over here. Now this resistor, I need this resistor to be 1800 kilo ohms, and I need this one to be 1.2 kilo ohms. This capacitor 22 nanofarads. This diode, nothing special about it. We won't change any value. The next one is this resistor. I'll just make it 10k. 10k. Okay. Now this supply over here, I want to make it 3.3 volts. 3.3 volts. Okay. So we are done connecting things up. Once you are done, the next thing to do is to click on this guy over here, Usain Bolt, and then run. Okay, so this menu has shown up because we didn't specify the kind of simulation we want to run. So we have transient simulation, we have AC analysis, DC sweep, noise, DC transfer, DC output. Now transient analysis is the kind of simulation where you specify an amount of time to run the simulation, and then in AC analysis you actually perform what we call a sweep. So you start from a certain frequency and then you end at a certain frequency. But in this tutorial we will just settle the transient analysis, okay, and we will simulate for 0.1 seconds. Remember that 50 Hz has a period of 20 milliseconds, which is 0.02. So we are actually running for 0.1, which is I think 10 times or so, 10 waveforms. Okay, so I'll click OK, and then this shows up. So if you head over to your circuit and you bring the cursor on any line, you can see the icon being changed. If you put it on a component, you can see something simple. Now if you put it on any line, you're actually probing the voltage on that line. So if I click, you can see that okay, let me make the amplitude 300, exactly 300. So I right click and then I make it 300. Alright, and then I simulate again. Alright, so by clicking here you can see that the amplitude here is what, 300 volts. Okay, but if I should put it on this icon, I'm going to see the current flowing through that device. Okay, it's shown in blue. Blue is not too visible, so what I can do is right click on this trace and then I change the color. I'll change it to red and then I just click OK. So this is the current waveform, and the current waveform for this resistor over here. If I want to show only this one, I can delete this one. There are two ways. First is to right click this and then choose delete trace. Another option would be to actually click on this resistor and click on it again. Alright, so that is this voltage here, and this is the voltage here. It's also in blue. Let me change it to red. Now it looks like a straight line because relative is not actually a straight line, it's an AC waveform, and this is a voltage divider here. Okay, and according to this voltage divider, the voltage drop across this resistor is around I think 200 millivolts. Now relative to 300 volts, 300 millivolts is insignificant. Okay, if I should get rid of this green trace here, you can see that it's actually an AC waveform that is from 0 to 200 millivolts. Okay, alright, so now let's probe the output. This is also alright, so you can see that the output is actually a square wave. Okay, let me select this. The output is actually a square wave and the input is an alternating current. So let's say you want to visualize the frequency spectrum of your signal. This is what you can do. You can right click and then you go to FFT. Then you select the traces you want to visualize. Right now these are the only two plots, that is N002 and N004. So they are already selected. I click on OK and I select both of them holding down Control, and it's going to plot the frequency spectrum for me. Now this is in dB. Maybe you may want yours in volt. What you can do is to select, right click on this horizontal bar here and then you select linear, click on OK. So this is now in voltage. Alright, so you can see very well that the naming of these waveforms are not really desirable and may not reflect the work you are doing. So what you can do is to add what we call a net label. So let's see how to add a net label. So I'm going to call this node here source. So I add a net label by clicking on this icon, and then the name, which I want to call source. Then I click on OK. Alright, now I'm going to name this side too, but I won't name it source. I'll just press escape and then alright, click on this to change the name. I'll name it VP. And then I'll name this side load. Okay, so I'll add a net label load, and then I'll click on OK. Alright, so let's simulate again. Alright, so now if I click on this, you can see that the waveform is on source. If I click on this guy, you can see the waveform. I don't like this color at all. You can see this waveform is VP. I click on this, you can see that it's what load. So that is net labels. It's actually used to name nodes in your circuit. Alright, so let's say I wanted to get rid of a certain waveform. Okay, let me choose the source voltage here. All I do is right click and then choose delete trace, and it's gone. Let me add it again. Another way would be to select visible traces here and then hold down Control and then click Vein Source, and then you click on OK. Alright, let me add it again. Alright, so let's use this method to actually get rid of it. Delete trace. Okay, so after deleting, I can see that the amplitudes for the remaining waveforms are very, very tiny and not really visible. So what I can do is to click on this graph here and then click on the auto range option. Alright, and that sets up the range for the plot, the vertical range. Okay. Alright, so let's say I wanted to plot the power dissipation by this resistor. Okay, I can't do that directly. I will have to use a trick because this node here is the voltage, and then we can actually plot the current through. Let me get rid of this load waveform and then let's see. Alright, so by plotting the current, you can see that the current is actually 180 degrees out of phase with the input signal, and the reason is that, well, when I put the mouse pointer on the resistor here, you can see the direction of current is leftward, which is not supposed to be the case. It's supposed to be going in the right direction. So what you can do is to right click on this IR2 and then you put a minus sign in front of it, and then you click OK. Alright. So for instance, if I wanted to plot the power dissipation of this R2 resistor, let me auto range again. Okay, if I wanted to plot the power dissipation for this resistor, what I'll do is I'll right click and then I'll go to add trace, and I want to plot. First of all, I have to get the voltage across the resistor, that is vein source. So this is one advantage of using net labels. It helps you to easily identify the nodes. Minus VP, VP instead. VP. Let me put a bracket. Alright. And then one here. Alright, and then I multiply that by negative IR2. Remember, negative IR2. And then I click on OK. So this is the power dissipation for the resistor. Let me get rid of the current here. Let me change. Alright, so you can see that the power dissipation is actually in milliwatts. Okay, it's in milliwatts. Okay, so that is one way to add traces which are not ordinarily allowed. Okay, so you can just do that trick, add a trace, and then that's it. Alright, so one more thing. Let's say I wanted another pane to plot a graph. So what I can do is to add plot pane, and this is another graph for me, and I can just add new plots to that side. Sometimes it's really helpful to do this if you want to compare two waveforms, but you don't want them on the same pane. That is what you can do. Alright, so that's all for this tutorial. I hope you enjoyed it. Please leave any questions under the comment section. Thank you.